Somewhere in the motor of your car, the speaker in your phone, and the turbine spinning behind a wind farm, there's a magnet made from an element you've probably never had a reason to think about. Its name is neodymium, and depending on the day, one country controls somewhere around 90% of the ability to actually turn it into something usable. Here's the part that should surprise you. That country isn't dominant because it has all the rock in the ground. Global reserves of rare earth elements are actually fairly spread out. China holds something close to half the world's known deposits, with real reserves also sitting in Brazil, India, Australia, and the United States. If this were purely about who owns the dirt, no single country should be able to hold this much leverage over industries as different as electric vehicles, wind power, and fighter jets. So how does one country end up controlling roughly 90% of global rare earth processing, when it only holds about half the reserves? By the end of this video, you'll understand exactly how that gap opened up, the real environmental price that was paid to create it, and one specific decision that country's own government made in 2025, a decision that shows exactly how far it's willing to go to keep that gap from closing. Despite the name, rare earth elements aren't actually rare in the ground. 17 different elements make up the group, and most of them show up in reasonably ordinary concentrations across the planet's crust. What's genuinely rare is the ability to pull them apart from each other cheaply. Rare earth elements occur bundled together in the same, or chemically similar enough that separating one from another requires dozens of repeated chemical processing steps, enormous quantities of acid, and facilities most countries have simply never bothered to build. Two elements sitting right next to each other on the periodic table can behave almost identically in solution, which is exactly what makes isolating one from the other such a slow, expensive, multi-stage process rather than a single clean extraction. That processing step, not the mining, is the actual choke point. A country can dig up rare earth and still be completely dependent on someone else to turn into the pure oxides, metals, and alloys that actually go into a magnet, a battery, or a missile-guided system. For decades, most of the world's, or wherever it was mined, ended up getting shipped to one place to actually become useful. That's the structural reason a country holding roughly half the world's reserves can end up controlling around 90% of the processing that matters. Mining rock is comparatively easy. Turning that rock into a usable material is where the real business lives, and where China spent decades quietly building a lead nobody else has matched. But knowing there's a gap doesn't tell you how it actually got this wide. That story starts almost a century ago, in a place most people watching this have never heard of. China's dominance here wasn't an accident of geology. It was decades of deliberate industrial policy, built while most of the rest of the world treated rare earth processing as somebody else's problem. The Bayan Obo deposit in Inner Mongolia, discovered in 1927, turned out to be the largest rare earth deposit on the planet. Rather than simply exporting the raw ore, China invested for decades in the separation and refining infrastructure needed to process it domestically, building deep chemical process knowledge, training a specialized workforce, and integrating downstream into metals, alloys, and finished magnets, according to industry analysis of the build-out. Western companies, meanwhile, largely optimized for short-term cost. The United States actually used to lead this industry. The Mountain Pass mine in California was once the world's dominant rare earth source. But as Chinese processing costs fell and environmental standards in the West tightened, mining and processing capacity outside China largely shut down instead of modernizing. It's a familiar pattern in industrial history. The country willing to accept the messiest, most polluting stage of supply chain often ends up owning that stage entirely, simply because everyone else walked away from it. By the time the rest of the world noticed how dependent it had become, China controlled somewhere around 90 to 95% of global rare earth processing, and an even larger share of finished magnet production, according to industry estimates. Today, mine production tells a similar but less extreme story. China accounted for roughly 69% of the roughly 390,000 metric tons of rare earth oxide mined globally in the most recent confirmed year of data, with the United States a distant second at around 12%. It's the processing gap between those two numbers, 69% of mining against roughly 90% of refining, that actually explains the leverage. None of that lead came for free, though. Part of how China built it so quickly and so much more cheaply than anyone else involved a cost sitting just outside a city called Baotou that most of the world has never actually seen. Part of why China could build this lead so cheaply is a cost most other countries simply weren't willing to accept. Separating rare earth elements from each other requires intensive acid processing, and the ore itself is naturally bundled with radioactive thorium and uranium. At Baotou specifically, the tailings left behind after processing get stored in a massive pond near the city of Baotou, an unlined reservoir reported to span roughly 4 square miles, holding waste with thorium concentrations that peer-reviewed measurements have found tens of times higher than surrounding background soil levels. That pond produces an estimated 8 million tons of new tailings every year, according to research on the site. Peer-reviewed sampling around the reservoir has found thorium concentrations tens of times higher than surrounding background soil, with radiation levels detectable well beyond the pond's own perimeter, carried by wind across the surrounding grassland. Rather than announce remediation, the state-owned operator disclosed plans in 2025 to expand the facility further, investing roughly $280 million in engineering work to increase its capacity, according to reporting on the disclosure. A New York Times investigation into the site the same year cited Chinese researchers themselves describing real risks, including landslides and pollution incidents linked to the scale of extraction. None of this is really a secret inside China. It's a cost that was paid deliberately in exchange for building an industry nobody else wanted to build under similar environmental rules. Whether you view that as an unfair advantage or simply a trade other countries chose not to make, the economic result is the same: refining capacity that would be extraordinarily expensive to replicate anywhere with stricter environmental standards, which is most of the developed world. The rest of the world got a preview of exactly what that kind of control could mean back in 2010, and the story of how it happened starts, of all places, with a fishing boat. That September, a Chinese fishing trawler collided with Japanese Coast Guard vessels near the disputed Senkaku Islands, and its captain was detained. In the weeks that followed, Chinese customs authorities slowed, and by some accounts, briefly halted rare earth shipments specifically to Japan, whose high-tech manufacturing sector depended on China for roughly 80 to 90% of its rare earth imports at the time. China had already cut its overall export quota by around 72% for the second half of that year, a move that predated the diplomatic incident. Whatever the precise mix of quota policy and informal pressure, the market impact was undeniable. Rare earth prices reportedly rose roughly 10 times over within about a year, with the most affected heavy rare earth elements seeing increases in the 400 to 600% range, according to industry analysis of the episode. The dispute itself resolved within about 2 months, once the fishing boat's captain was released. But the lesson stuck. Japan spent the following decade actively diversifying its rare earth supply chains, funding alternative mining projects abroad, and pushing its own manufacturers to redesign products around less rare earth-intensive technology wherever possible. The episode became the standard case study for exactly what a country holding this much processing concentration can do to global prices, intentionally or not, virtually overnight. A lesson the rest of the world would need reminding of 15 years later. Even today, those 2010 numbers are still the reference point the entire industry measures every new disruption against. To understand why a lesson like that could ever need repeating, it helps to see just how deeply these elements are actually woven into the modern world. Not just phones and cars, but the machines an entire military runs on. Neodymium and praseodymium form the base of the strongest permanent magnets available, the kind that power electric vehicle motors and wind turbine generators. A typical EV motor uses 1 to 2 kilograms of these elements, and industry forecasts suggest the EV sector alone could need over 50,000 tons of rare earth magnets a year by 2030. Every megawatt of wind turbine capacity using a permanent magnet generator requires roughly 200 kilograms of rare earth material. Defense applications go even further. Estimates of the total rare earth content in a single F-35 fighter jet vary by source, from a widely cited figure of around 400 kilograms up to nearly 1,000 pounds in some defense industry analyses, spread across flight control actuators, radar systems, and sensors. A next-generation naval destroyer reportedly carries 2 to 2.5 tons of rare earth materials. A nuclear submarine carries roughly 4 to 4.5 tons. Multiply figures like that across an entire modern military, and the totals involved run into thousands of tons of materials sourced almost entirely through a supply chain one country controls the processing end of. The dependency runs deeper than raw tonnage. China refines an estimated 99% of the world's dysprosium and terbium, 2 heavy rare earths that are specifically what let magnets survive the extreme heat inside a jet engine or missile system without losing their strength. In 2015, the Pentagon's own program office allowed Lockheed Martin an exception to standard procurement rules, permitting F-35 magnets sourced from a Chinese supplier, simply to keep the over-budget program on schedule. That single exception says as much about the depth of this dependency as any statistic does. For a decade after that, the dependency just sat there, mostly unaddressed. Then, in April 2025, the country holding that 90% choke point decided to actually use it. Beijing introduced formal export licensing requirements on 7 specific rare earth categories, including dysprosium, terbium, samarium, and yttrium. Precisely the heavy rare earths defense and green energy manufacturers depend on most. This wasn't the informal customs slowdown of 2010. It was a deliberate, published policy. The effect was immediate and measurable. Chinese exports of rare earth magnets and compounds are reported to have fallen roughly 74% year-over-year by that May, as the new licensing system slowed shipments to a crawl. Chinese commentators have openly described the move as a trade war countermeasure, a calibrated pressure point aimed squarely at Western defense and technology supply chains. The retaliation cut both ways. As Western governments pushed to build alternative supply, China responded by adding the 2 most prominent American challengers, MP Materials and USA Rare Earth, to its own export control blacklist on June 22, 2026, a direct shot at the companies most capable of eroding its position. It's a striking move on its own terms. The same country that dominates the processing side is now formally restricting its own market from the very companies trying to build an alternative to it. By the second quarter of 2026, major Chinese state-linked producers China and Northern Rare Earth Group and Baotou Steel raised prices by roughly 45%, citing tight domestic inventories and stricter environmental standards raising their own processing costs. Bloomberg Intelligence projects the neodymium-praseodymium market alone could reach $10 billion in value in 2026, with renewed trade tension as a direct driver of that growth. Rebuilding an industry that took decades to lose isn't cheap, and it isn't fast, but real money is now moving to try. MP Materials, which operates the reopened Mountain Pass mine in California, received a $400 million equity investment from the U.S. Department of Defense in 2025, part of a broader push that has included more than $439 million in Defense Production Act funding across several rare earth processing companies. Starting in July 2025, MP Materials stopped selling its output to China entirely, redirecting its supply chain fully toward domestic buyers. The Pentagon has also set an effective price floor of $110 per kilogram for MP Materials' neodymium-praseodymium output, roughly double prevailing market prices, specifically to keep American processing economically viable even while Chinese producers keep global prices depressed. Lynas Rare Earths, based in Australia, with processing facilities in Malaysia and a newer plant in Texas, remains the largest rare earth separator outside China. Bloomberg Intelligence's own 2026 outlook projects global neodymium-praseodymium production could grow more than 4 times over by 2030, reaching 64% of demand from producers outside China, a scenario built on roughly $10 billion in public funding commitments expected globally in 2026 alone. That projection assumes real execution risk gets managed successfully. Mining permits, environmental approvals, and specialized workforce training all take years, and the West is essentially trying to compress a process China spent decades building into a much shorter window. Even under that most optimistic scenario, though, the honest read is that China Northern and China Rare Earth Group are expected to remain dominant in the near term. Most rare earth-producing countries outside China still ship their concentrate to Chinese processors for final oxide production even today. The mines reopening in the West are real. A finished mine-to-magnet supply chain that doesn't touch China at any step remains, for now, mostly a work in progress rather than a solved problem. Remember the promise at the start of this video, that one specific 2025 decision would show exactly how far China is willing to go to protect this gap. That decision was the blacklist. The same country that spent a century building the world's only real rare earth processing base looked at the 2 companies most likely to end its advantage and simply cut them off from its own market. That's not a country worried about losing this fight. That's a country making sure it doesn't have to find out. Pull everything else together, and the real story here was never really about rare rocks. It was about who was willing to build the unglamorous, chemically brutal, environmentally costly infrastructure required to separate 17 nearly identical elements from each other at industrial scale, and who was willing to let a tailings pond outside Baotou grow to 4 square miles, and then grow it further in 2025, rather than pay to contain it more carefully. China made that bet decades ago and let a domestic industry compound around it. The rest of the world largely didn't, until it suddenly needed to. The 2010 dispute over a fishing boat showed what a 72% quota cut could do to global prices almost overnight. The 2025 licensing rules showed the same lesson at a larger, more deliberate scale, aimed directly at the defense and clean energy supply chains the whole modern economy actually runs on. Both times, the leverage came from the exact same place. Not the ore in the ground, but the 90% of the world's capacity to actually do something useful with it. Billions of dollars are now moving to close that gap in California, in Australia, in Texas. Whether that money closes it in 5 years or 15 is still an open question, and every industry estimate in this video comes with the same honest caveat. The West's own experts still expect Chinese producers to dominate for years to come, even as that gap slowly narrows. What isn't in question is the lesson underneath all of it, that in a modern supply chain, owning the raw material was never really the point. Owning the one step nobody else could replicate, the acid baths, the trained chemists, the tailings pond nobody else wanted to build, always was.